Welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it. Come back. And after this, we go to Throwback Thursday, where we look at a question from about 25 years ago. Okay. In the XY plane, we have a graph where K is a constant, and it has a y-intercept of 0, 2. What is the value of K? Oh, isn't the y-intercept where x is equal to 0? Yeah. Where x equal to 0. So therefore, we just plug x equal to 0 in here. We know the answer has to be, y has to be 2, and then just gives us an equation for the unknown, which in this case is k. Now you have to know that anything to the 0th power is 1. So this comes down to 2 is equal to negative 14. Well, times 1 plus k. So then we solve for k, and k is equal to 16 by adding 14 to both sides. So that's a pretty straightforward question. Right. Yeah, you have to know that we'll go into what you have to know in order to do it. That's what we talk about those things at the end. Seth, what do you think?
I agree. The whole business is knowing what they mean by y-intercept.
Right.
That's what that means for first a curve, and second the equation of a curve.
Right.
Right, and then the what it means to what for a point with coordinates to have the coordinates satisfy the equation. What a point on the curve means in terms of the coordinates in the equation.
Right.
And then a little bit of arithmetic together with exponentiation and this rule that any non-zero and even 0 raised to the 0th power is 1.
Right, yeah, so there's actually a lot of stuff that the SAT people, when they design this question, expect you to know. So let's just go through the 4 questions. Calculator, well, this is obsolete. This was from a non-calculator part of an old test. So now, if this was given on the digital SAT, you have a calculator, and calculator doesn't really help you much in any practical way. How would you do this question differently from a question in school? Probably not.
I know. I think if you need to use a calculator to find that a number raised to the 0th power equals 1, it would be really wise to learn to do that without a calculator.
Yeah. Right. Okay. And then. If this question was given in school, you wouldn't really do it any differently, and it's a moot point whether you would start with the answers. There are no answers. This is not a multiple choice question, so sometimes we ask, well, if it's multiple choice, can we just look and see what the answer is, or just plug the answer in? It's obsolete here. But until we get to the main question, what are the key points? Seth said exactly that. I just want to make an emphasis on one of the points Seth said, but really, really, really make an emphasis of it, that if you have an equation and if you have a point that is on the graph, this point satisfies the equation. So unbelievably important.
The coordinates of the point, yeah. Yes. Yeah, that's what it means.
The x value of 0 and the y value of 2 satisfy this equation. So what that does is if you plug that in, you know everything in this equation except the k, which means the k becomes the unknown, and then you solve for k.
Yeah.
Such important.
Oh yeah. You need to know what's the difference of x-intercept and y-intercept. Well, the vertical axis is the y-axis.
Right, but we're not talking about the x-intercept.
I know, but x-intercepts. There are some questions with x-intercept.
I know, but let's
so I want to show how to avoid confusing x-intercept and y, and they say y-intercept. How to figure out how to remember what that means.
Okay, but let's finish up this discussion first about the concepts in this particular question. Then move on to the other things, because otherwise it's just going to get too confusing. So that's such an important point, that if you're given a point on the line if you're given the point on the graph, it has to satisfy that equation. And then, of course, Seth said anything to raise to the 0 to the power is 1, solving equations, and also knowing what the y-intercept means. The y-intercept, actually, they didn't even have to say y-intercept. All they had to do was say the graph goes to the point 0, 2. They didn't even really have to say y-intercept. And also, if they said y-intercept of 2, then they didn't really have to give the point. So they were really being nice here. They slammed it down, y-intercept of 0, 2. They gave you sort of duplicate information, which was really nice. So, yes, and of course you have to know the y-intercept is where the graph intercepts the y-axis, which happens when, oops, I didn't label my axes, that's bad, when x is equal to 0. Okay, now, you want to talk about the other intercept? And I'm going to try to get rid of this annoying thing, but I don't know if I can. Come on, go away.
So I'm writing in green. The y-intercept, of the curve that's curvy, it's called the y-intercept because it is on the y-axis.
Okay.
And it happens to be the point that's on the curve and on the y-axis. It is a point where x is 0.
Yes, very potentially.
So that's
confusing.
where. So you do the calculation. The number that you have to calculate is really an x number, right? So the y-intercept is on the y-axis, and it is a point, if there are multiple ones, a point, which there aren't when you have a function, the point on the curve where x equals 0.
Okay.
So
right.
it's backwards. Yes. The y-axis is where x equals 0.
That's right.
And the x-axis is where y equals 0.
Right. Yes.
Doesn't that seem confusing?
Oh, and it's for someone like me who gets my left and right confused, and my x and y confused, and my up and down confused. Oh, it's positive and negative confused. It's a disaster.
Let me do that again.
So what I do is I write
Here's
down.
The x-axis. Yeah, talk. Just keep talking.
So what I do, every time I do this, and I did it right here, you can go back to the videotape. I drew an x-y axis, and I plopped down the y-intercept so I could really, really see it. Because if I do it abstractly in my head, I'm going to get the x and y confused. So I have to physically draw it in order to really make sure I'm getting it right. And if you get your x and y's confused and you're confused by this, please take a second and just make a little picture like I did. See? Little picture. Because it's potentially confusing. In fact, no, it is confusing, not potentially confusing. So, yeah, you got to be really careful. Okay, we're done?
Yeah.
Okay, so today's Thursday. So we're going to go back to a review book that the SAT published, I don't know, like in the late 1990s, when the test had a bit of a different feel to it. It was test a little bit less on what you did in school and a little bit more on just sort of using your brain. So let's look at this question. It may be a question that they would give now, but this feels different. So here is our, come up. Oh, there it is. Sorry. There it is. Okay, here's our Thursday throwback question of the day. In the figure above, if the figure above were redrawn to scale so that A was equal to 30. Oh, so they're talking about A degrees. Oh, that's interesting. A was 30. So maybe we should, okay. And if segments FA, FB, FC, and ED were extended infinitely upward, how many points of intersection would there be in addition to E and F? Oh, oh, oh. So wait, does it really matter what these degrees are? This is 90. This is 90 degrees. Oh, wait, hold on. I should annotate using Zoom. So this is 90. Okay. Wait, look. This is 90. Come on. Stop. Stop. Oh, stop, stop, stop. Okay, I'm going to have to annotate. Okay, this is 90. And this is 30. 30. That would be 60.
Oh, watch out.
Oh, that's interesting. That is seriously
scale.
not drawn to scale. Wait, am I doing this right?
Yes, you're doing something very interesting. Keep going.
Yeah, which means, so let's draw it to scale, okay? Let's draw it to scale. So let's put a 90 here, and let's put a 30-degree angle here. That would be point C. Let's do a 60-degree here.
No!
Oh,
What's
shit.
30 plus 60?
Oh, damn it. See, this is like the old SAT for you. You know, mistake we all. Oh no. Oh no. That's 90.
B
they're never gonna be. They're never gonna be.
That's right angle.
Oh my god. I hate the old SAT. So you would never get a question like this in school. But the new SAT, basically every question you could potentially get in school. How many points of intersection? So there's only one more. How many points of intersection would there be in addition to E and F? So you also have to know how to read English. Wow. So there will be only one point.
Consider, what about the FA line?
Wow, that one is so clearly like, this is 90. That's 30. That's out to 120. That's out of here. That's going the other way. That's never going to intersect. That's never going to intersect the big blue line. We'll call this the big blue line, okay?
Okay.
Right?
Yeah.
So that's never going to... Oh, no. I wonder whether I would have caught that. You caught it, but I wonder whether I would have caught that on my check.
Well, I think I would have been caught by forgetting that the extension is upward.
Really?
Because normally when I think of extending a line, I think of it always extended in both directions. And if FA is extended in both directions, it intersects the vertical line below the diagram. But the question says that these lines, these segments, are named with the origin of the segment first, and it says they're extended upward, and they draw arrows. No, they don't. They don't draw arrows. You drew the arrows. They draw.
Yeah, they didn't draw arrows.
So upward.
Yeah. Oh, yeah. Wow. That would have been. I bet they debated that.
So people might, if they don't read into this, that the extension of, so this is really the line AF.
Right.
This is a picture of the line FA.
FA, yeah.
Yeah. And so if they don't catch it, FA is extended upward. It's not extended downward.
Right. Yeah. So if they would have said if they wanted to go both ways, they would have said extended infinitely in both directions.
Yeah.
Right.
Yeah.
Yeah. So there were
lots of a careful reading type of question, and and then I think it's important to recognize that when you say when a figure is not drawn to scale, It means that the angles are different between the two drawings. The drawing of the angles in the drawing are wrong
Yeah.
when the
Right.
drawing is not done to scale.
Right. It just look. It doesn't. It's not drawn. Well, it's not drawn to scale. It's not drawn the way it looks like it is. Basically.
Well, it's to scale means that well, what does it mean? What does it mean? Is it what it's vague what it means. It's vague what it means. Oh, in the context of SATs, the I don't.
They just.
It basically, I think it should be. It's simplify the issues of what it means for a drawing not to be in scale. What does it could be? What's the difference between a drawing not to scale,
Right.
and a drawing that is not a drawing? Having one drawing is not a drawing of a figure,
right.
and a drawing is a drawing of a figure, but it's not to scale. What's the difference?
There is not really. I mean, the drawing not to scale has some of the features of the drawing, but it's not an accurate portrayal of the numbers or of the relationships that are told to you. It's not an accurate portrayal of the relationships of the numbers. Yeah. So, yeah. So they basically don't. They're basically telling you don't use the figure to. Don't use the details of the figure to do the problem. Like redraw it.
This drawing and this drawing. Okay, drawing 2, and drawing 3.
Yeah.
Are any of these drawings of other drawings but not to scale?
I have no idea. I don't know what you mean.
3, it looks parallel.
Yeah.
Here we have a line that's looks B. This line here, FB, looks oblique.
Yeah.
It looks like it makes an acute angle with FE, but it really makes a right angle with FE.
Right. Yeah.
And similarly, FA looks like it makes an acute angle with FE, but it really makes an obtuse angle with FE.
Yes. Yeah. I know that they did this on purpose. Yeah. They did, and I looks like I may have been.
Yeah. So I love to criticize problems.
I know. Well, that's the whole point. This is the old welcome to the old SAT.
And the fact of life is that problems like this, where the problem has problems, there are indeterminate features of the problem, in addition to the question of what the solution might be, is the way problems are the kind of problems that you run into in real life.
Yeah, well, this is highly not real life. Unfortunately, with the book, sometimes in the older books, they told us what the difficulty level of this question is, and also what percent of the people got it right. Let's just make sure we got it right. This is question 31, section 5. 31, section 5, the answer is B. Okay, yeah, so they agree with us. It's too bad they don't tell us what percent of the people got it right or how difficult it was. But it's a tricky question, really tricky question. And it's possible I would have been fooled. But I don't know. I didn't check it. And we don't go through all the stuff we go through, like what's the main idea of the question. Throwback Thursday of the day, we just give ourselves a break. So, okay, I guess that's it, right?
Yeah.
Okay, so say hello to Seth. He is a PhD in math from MIT. He's been teaching computer science at SUNY Albany for many years. He's now retired. I'm his brother Joel. I have a PhD in mechanical engineering from Columbia University. And we're here to hopefully offer different approaches on solving SAT math questions. We try to do one question a day. On Thursday, we have that extra question. And hopefully, we offer different ways to do the problems, different insights, a little background. And we always ask, what was the main idea of this question? Focus on the main idea of these questions when you're studying for the SAT. And when you're studying for the SAT, do as many practice questions as you can and practice on your weak points. You can go to Khan Academy. They have a digital SAT course where they outline all the topics and they give them a lot of questions on each topic. So practice the topics you're weak on, practice the topics you're strong on so you don't make any stupid mistakes, and then go to the SAT website and do all the SAT practice questions they have and just keep learning from your mistakes. Okay, I guess that's it, right? And please give us comments on our videos, and if you have any SAT math questions, please email them to us at, and I'll slow down, SAT math question of the day at gmail.com. And Seth, do you want to finish off with what you always finish off with?
That email address is printed on the title page, the first page of our YouTube channel.
Exactly. Okay, everyone, have a great day.